Hi, I'm from the Customer Success Engineering team. In this series of short videos, we're taking a look at the baseline recommendations for configuring Zscaler Digital Experience, or ZDX. This is part 2, configuring applications and probes. Once you've enabled ZDX from the Zscaler Client Connector portal, the next step is to configure applications for monitoring inside the ZDX admin UI. There are two ways to do this. The first is to leverage the predefined application configurations that are included in the ZDX admin UI. This list includes a number of the most commonly used enterprise SaaS applications, such as Microsoft Teams, Outlook or SharePoint, ServiceNow, Okta, Salesforce, and WebEx and Zoom. Since these are pre-configured, you don't have to go through the full configuration. ZDX already knows what destinations to monitor for these applications. Enabling these will also automatically create and enable the corresponding cloud path and web probes. More on that in the next video in this series. The second way is to create a custom application definition. Doing this will require you to define, configure, and enable at least one probe manually, but allows you to monitor any SaaS application or URL. However, before defining any applications, there are a few considerations that are worth keeping in mind. The first of these is that to prevent ZDX monitoring from itself negatively impacting user experience, the number of ZDX probes that can be run on a user device is limited to 30. With that in mind, it's important to carefully select which application should be monitored by ZDX to ensure that you select the most important and relevant applications for this purpose. Zscaler recommends choosing applications to monitor which fall in these three categories. The first category is business-critical applications, that is, those applications that are critical from a user productivity and business continuity perspective and need to be monitored across the board. For example, this category would include your key productivity and communication apps, such as the Microsoft 365 suite, Zoom, etc. The second category is group-specific critical applications. Much like the business-critical ones, these need to be monitored continuously, but this category contains applications that are critical only to specific groups. An example here would be something like PagerDuty, which is critical for operations teams, but not sales employees, or vice versa for Salesforce application. The third category are unstable applications that generate a high volume of incidents and incident tickets, so-called noisy applications. Monitoring these lets you get the most value out of ZDX by getting proactive notice of issues with these applications. Unlike the other two categories, the list of applications belonging to this one is most likely going to be dynamic. Applications will not always stay unstable or stable, and so you may choose to monitor or stop monitoring applications in this category over time. As a result, it's recommended that you review applications in this category periodically, for example, on a quarterly basis. The second consideration to keep in mind is that to get the most out of ZDX's network monitoring capabilities, you'll want to make sure that you monitor applications that are accessed in a variety of ways and from a variety of locations. Generally, it's recommended to make sure you configure at least one application for each of the following three access methods for each location you want to monitor from. Applications which are accessed directly over the internet rather than through ZIA or ZPA, which will allow you to eliminate Zscaler from the potential cause of network issues. Applications which are accessed through Zscaler Internet Access to monitor ZIA performance in the application path. And finally, applications accessed through ZPA for the same reason. The final consideration is around applications with regional services. For example, let's say SAP is a business-critical application, and there are two separate instances, one for Europe and one for the Americas, that are independent of each other and can therefore be down independently from each other. In cases like these, having both services grouped under a single ZDX application runs the risk of reducing the accuracy of metrics for both services and for SAP, diluting trend data and stopping you from understanding how each instance is performing. In that case, it's important to configure both instances as separate applications inside ZDX, for example, as one SAP Europe and one SAP Americas application. This will make sure that dashboards report accurate status information for any particular service. An additional note for ZDX Advanced and Advanced Plus's license holders. Since you're entitled to a higher number of monitored applications, and since, as mentioned previously, users can only have 30 probes assigned to them, it's recommended that you only assign probes to users and groups that need access to an application. This will stop probes from running on the end user's device for applications they'll never use. For applications accessed via ZPA, in cases where your ZPA access policy blocks access to certain applications, this will also prevent the probe from falsely reporting an issue. In the example here, we can see that the applications used by each of our user groups are different. Neither the help desk or operations groups need access to Salesforce, and only operations needs access to Azure and PagerDuty. In this case, probes for Okta and Microsoft 365 should be assigned to all users, but the other probes should be limited to their respective user groups. Now that we've discussed configuring applications, let's talk about probes. Probes collect and log certain data for your configured applications. Predefined applications have pre-configured probes created by default when they're onboarded, whereas custom applications require probes to be manually created. At least one web probe is required to enable most applications, with the exception of network applications. There are two types of probes, web probes and cloud path probes. Both of these monitor different things and generate different metrics. In the case of web probes, these work by sending a request to the server and monitoring the HTTP status code received in response. Web probes generate the following metrics: page fetch time, DNS time, server response time, and availability. Since the status codes received when probing the destination URL are what determine if an application is available or not, it's important to make sure you list all HTTP response status codes that map to the application being available. Otherwise, availability metrics generated by the web probe will not be accurate. The HTTP response status codes configured here should be based on how the application responds to an unauthenticated HTTP request. Newly created web probes come with this field pre-populated with common successful response status codes. The second probe type are cloud path probes. These are used to provide path visualization for the different hops in the network path between the user and the associated application. These generate hop count, packet loss, and latency metrics. The main things to watch out for when configuring cloud path probes are, first, the protocol used. The choice here is between ICMP, TCP, or UDP. If you select the adaptive option, the probe will automatically select the best protocol for each leg of the path via an auto-discovery process, based on the protocol with the best latency and least packet loss. It's generally recommended to go with adaptive here, unless you know a destination will only respond to a specific protocol. Secondly, the packet count, which is the number of probe packets sent per hop. The recommended values here are 3 for internal applications, 5 for SaaS applications, and 11 for UCaaS applications. Note that it's possible to configure cloud path probes to use reverse cloud path while on trusted network. This is useful when the forward cloud path probe cannot reach the egress point due to corporate firewalls or other network devices. In this case, the cloud path will be measured by sending probe packets from the ZIA or ZPA service edge back to the user's egress location, providing visibility when forward path probing is blocked. It's recommended that you only use this option as a last resort and prefer allowing the configured ports through your firewalls instead whenever possible. Finally, a note on configuring applications with the network application type. Normally, applications require at least one web probe for monitoring, but it's possible to monitor applications of this type using only a cloud path probe. This is especially useful for non-web applications, which don't have a web front end for ZDX to reach. This provides full end-to-end latency visibility and allows ZDX to generate accurate ZDX scores for these application types. With that, that's it for this video. Thank you for watching.